Hello and welcome back. We're going to try something a little bit different today. We're going to do a little bit of live coding to be able to kind of better illustrate this idea of static and final keywords in Java code. So I want you to imagine for a second that every single student at the university shared a campus map. So if you needed to know where to go, you had to pull out a map, and the map you pulled out, if you didn't have it, you had to go grab it. Everybody has to share the exact same map. If somebody else drew all over the map, you would then see their drawings, and you'd be like, well, this is really annoying, and be annoyed about it. Imagine sharing a Google Doc, all of us sharing a single Google Doc, and it's the only doc that we can use. This is the idea of a static class member. All right, so we are going to first discuss this idea of static and what it means for something to belong to a class instead of an instance, and how we sort of access that information. Now, let's just start with this idea of static in public class static final example. So my main class here. Let's just start with this one right here. The fact that this says static right there. Make that a little bit bigger. When we run our code, we always just push run. As a user, I push run in VS Code or whatever I use, and magic, code runs. Okay, cool. But what actually is happening? Well, let me tell you, what actually is happening under the Java hood is we are running a line of code that looks something like this. And then like some empty string array. Okay, so this is the line that we're actually running of code. We are referencing this static method based on its class name. It's public, so we can access it. This is the line of code. I mean, obviously this is a real array, but this is the line of code that Java is actually running when we try to access a static method, because static for our terms effectively means class, and it means it belongs to this whole class, not a single instance of the class. Let's take a look at an example with some visualizations. I've written some code here that I'm just going to go through before I actually run it. I've got a class student, and inside I've created a class level variable called int class level ID. I've also created an instance level variable, instance level versus class level. Oops. And this is a instance level variable called student level ID. So these are going to be two different IDs associated with student objects. This one is associated with the whole class. This one is merely associated with an instance. A quick aside, this site is called pythontutor.com, and you absolutely can visualize Pythonic code, but also Java code, and I strongly recommend it. What I've gone ahead and done in here is I've created two different constructors so that we can really see what's happening given the two different options here. I'm going to actually set this to like 100, or to 10, pardon me. So we have our public student constructor, our default constructor with no parameters. And all we're doing is setting this class level, the student level ID equal to whatever the class level ID is. Here we have a different constructor. This constructor will pass in, an ID, and it will set both of these to that ID. If we look in our main class down here, what do we actually have going on? Well, we have the public if we look at our main class down here, what do we actually have going on? Well, we have first the student being created, stud1, with the default constructor. We should expect that it will come into the default constructor up here and set the student level ID to 10. Next, we have this student fresh ID, and this one is going to equal new student with a parameter of 1000. What can we expect to happen here? It should go into this constructor over here on line 9, and it should set the student level ID to 1000 and the class level ID to 1000. We then have student and they're using the default constructor as well. Here, we understand that it will bring it back up to the default constructor with no parameters, but the question is class level ID going to be equal to 10, or is class level ID going to be equal to 1000? Now this 1000 was set inside the fresh ID instance. So it was set internally to this instance of student. However, it is a class level static variable. So let's go ahead and visualize this and see what the heck is going on. I'll go ahead and just click run. Okay, and now we're ready to run our code. So just a quick understanding of how this tool works. This red arrow over here, this is going to be the line that's about to execute in our code. Once we see a green arrow, that will be the one that just executed. Our code is over here. We can click next through each of the steps as we run through our code. You'll notice that over here on this side of the screen, we have our frames. The frames are the line and the class in which or method in which we're calling. And then any objects that created will be over here. The frames is effectively what gets stored on our runtime stack. And then the objects is memory allocations on the heap. So it's important for us to understand that difference. So once I push next, we'll see that this line of code just ran. See the green arrow on line 18, student, stud1 equals new student. That line of code just ran, which means we're now going to come up into this student class and see what the heck is going to run as part of that new student memory allocation. And once this finishes executing, we come down here and we actually can see that we have created a static field that is attached to the student class called class level ID, and it is equal to 10. Now, once we have finished running this int student level ID line of code, we can see that we've created an instance variable called this right now because it hasn't actually been assigned over to student. But we can see that we have this instance variable. And what do we know about it so far? Well, it's just assigned a default value because there's nothing here with an assignment on it. So that default value is 0. Once we actually run lines 5 and 6 here and we execute on our constructor, we can see that the student level ID did change to 10 because it took the value from class level ID and poured it into the student level ID, and that's how we got that value. Once that constructor finishes running, we head back over to main, we return that instance reference, and it gets assigned to student 1. And so now student 1 is equal to the data that we just assigned it. The next line to run will be fresh ID, and the exact same thing will happen again. Here our public student ID gets passed in as 1000. At this point, we have an instance level student level ID, but we haven't actually run an assignment yet, right? We're on line 9. We haven't run the assignment for this one, so you can see it's still equal to 0. As soon as we go into the constructor and call this student level ID equals ID, we're going to go ahead and get 1000 because that is what was passed in, and this line of code says student level ID should be equal to ID. Only now we've also got this class level ID equals ID. And when we run this line of code, well, Java's going to say, sure, I can change the class level ID variable to be equal to whatever is in ID. Where is this class level ID variable? And it looks at the local level and it doesn't find one. And then it looks at the instance level and doesn't find one. So then it goes to the class level and it finds one. And so what will happen is we will have now changed that static field to 1000. It's no longer equal to 10. If we continue with our code and we go down to run student and we run this new student, we can see once again that the instance level student level ID is defaulting to 0 because we didn't assign it up here. As soon as we go into the constructor and we run that line, it does assign it to the student level ID, but oh no, we've changed it from 10 to 1000, so now this one is going to get the value 1000. I'm just going to run the next line here to all done so that we can see the final state of our program and we can see exactly what happened. we can see that when we change the static level ID, even though it was inside of an instance, we ran into a problem. We changed it for everybody. Now, sometimes this is what we want. We can use this as a counter. So for example, perhaps instead we start our class level ID at 0, and every time we get a new student ID, ID, we want to increase that ID. Now let's get rid of this constructor. We don't need it. And let's do this instead. Let's visualize this code and see what happens. I'm going to run through it a little bit faster because all of this setup is the same. But now once student 1 is done getting created, we'll see that it gets set to be that class level ID. And once it's done being set up, class level ID is going to increase. And look at that, it goes up to 1, while the student level ID is still 0. All right. Next time we make a different student, the student, fresh ID in this case, is going to be, I need to turn that off, sorry. The fresh student ID is now going to get the class level ID, which is 1. And once that's finished running, it will do class level ID++, and the class level ID becomes 2. And we're able to use this static integer kind of like a counter for how many of these students we have created. Lastly, we're going to run that student for our third and final initialization of a main method student. And here our student class level ID is 2. So we will assign the student level ID to be 2. Right there, it's been assigned. And then we will increase it to 3, ready for the next student to use. This can get a lot more complicated if our class level variables are mutable. Things can get really messy and really confusing. And we're going to talk about how to ensure we're more careful about this in a minute. But we can now see that there is a purpose to being able to change a static field. Right? There is a purpose to these class level fields, and in this case we're able to keep track of perhaps it's the number of students registered, or perhaps it's their ID, or maybe it's their place waiting in line for something. And we can see why having it attached to the class level rather than an instance level might be beneficial. Let's say that instead we don't want this to be changeable. Let's alter this example here just slightly so that we can find ourselves in a slightly different situation. Instead of this keeping track of the ID, let's say the university that they are enrolled at. And let's say we want to set this to be the University of, man, this is going to be too long. I don't like that it's running off the screen. U of M. And string level ID can just be the same. That's fine. Whatever. No, string name. We might as well change this whole thing if we're going to make some changes here. String name. Now, let's say we actually string university. That's fine. And let's say we want to be able to tell our program that our student that we are now enrolling is enrolling at the U of M. We'll say university enrolled. Maybe we could call it institution enrolled, perhaps. Institution enrolled. There we go, and we set it to this just like that. Now, we do have maybe multiple institutions that want to use this, right? Maybe the International College of Manitoba needs to use our system. Maybe different programs like the Extended Ed wants to use our system, and they like to keep track of their institution enrolled slightly differently. So we allow the ability to set the institution, and then we'll just set this internal instance variable to that institution. No problem. So student 1 can be at the U of M, fresh ID can be at the U of M, and let's rename these to something that makes more sense now that we're not trying to show mistakes. This student can then be enrolled at ICM. Maybe this one is enrolled at Red River. Who knows? We can see that we can set these differently. Let's just visualize this very quickly before we get to the other point I'd like to make here. So I will just push last, run through the whole thing, because there's no reason for us to go through it slowly again as we just did with the ints. It's exactly the same. So at the end of everything, our institution enrolled at the class level is still U of M, and Stud 1 used that information. So, oops, I didn't know that it was going to do that. Come back. I've literally never run that before in my life. There we go. So we can see it's set to the U of M. We can also see Stud 2 and Stud 3 are using their own versions of strings that they passed in right over here. No problem. But what if we don't want to allow anybody to ever change the institution enrolled variable? Whoops. Because as it stands right now, somebody could still come in and change the institution enrolled to whatever the institution is that gets passed in. And this becomes a problem because if another student enrolls later, after our final individual gets enrolled, I'll do the same thing again, and I'll just push, oh, did I spell it wrong? Apologies. There we go. So now if somebody enrolls after our final student, like Stud 3 enrolls, so now if somebody enrolls after that final student, Student 3 enrolls, we'll now have a Student 4. Student 4 no longer got that U of M default, they got the ICM one, right? So we've allowed that ability to change our static level variable. If we don't want to allow this, we can use final. You've seen final before, you know it can be used on local variables, you know it can be used even on instance variables. Once it's been set, it can't be set again for that instance, for that specific object. It can also be true at this level. Once we put something as final institution, we need to make this capitalized. Now this will be great, this will work just fine, this will make our code no longer compile, just as it would if we were trying to use final and change the value on any type of variable. Let's give it a try just so that we can see we do get an error. There it is, error, cannot assign a value to the variable institution. So now even though we've extended our program to allow other institutions to use this code, you cannot change the default. So it will stop a new developer coming in trying to change the default. When we run our code now, we'll see that that Student 4 does go and sort of fall back on that default value since we weren't able to change it to ICM at any point. We couldn't actually change the default. So this is how static and final work. Again, I did say we can use final in other scenarios as well. So perhaps a private final Boolean deactivate or activation status. When a new student is created, let's say we want to have a, activation status is going to be true. They're a new student. They're active in our course. Activation status becomes true. Now, as long as we're only relying on defaults, this is totally fine. We can do this. However, now we're unable to change this value, which means if a student public void graduates, this would fail. Line would fail. Because we cannot reset this activation status after it's been set once. So even though this is static, the final part of it is what actually prevents us from being able to do that. So this code will also fail for the same reason as before. We cannot assign a value to final variables. So in this scenario, maybe it doesn't make a ton of sense to make this final because the activation status of a student can change. But if we think about things that cannot change, like a student's birthday perhaps, private, final, and birth year. If we allow there to be some way to set the birth year of a student, set birth year. Let's set it here, int birth. Birth is equal to, oh, whoops, birth year. Oh, it should be, this is why I'm confusing myself. Birth year is equal to the year that they get passed in as birth. We'll just do it like that. And now we pass in their birth year. Oh, that's not a year. Oh, I need to initialize birth year. Whoopsies. By default, we'll say, oh, I don't remember how to use date time. I'll just pick a random year. That's fine. Now we will see that we can also give everybody these default, I'll just go like this, these default or final birth years, right? So we have a default to fall back on in the case that somebody does not provide a birth year. Maybe we assume that that means for some reason that they were born in 2001, but if they gave us a birth year, we can set it. And we've created these to be constant, final, we've capitalized them so we're aware that once these have a value, they cannot be changed. All right, so we can kind of see that there may be some situations that a static variable could cause a bug, and we definitely want to be careful of when we're using them and asking ourselves, why are we using them? And if we need to, there's a good chance, especially in our cases, that we might need to pair it with a final keyword. Depends if it's something that we want to have changed, like some kind of population counter, or if it's more like a default value that we can all share because it's true for the whole program, and then it can just be a final static variable. In the next video, we're going to see how methods and constructors can share the same name. We're going to do a little video on overloading. We already started to see that right here when I had two constructors, each with the same name but different parameters, but we'll dig a little deeper into that and also discuss it at method levels as well. Thanks everybody, and I'll see you in the next video.